Okay folks, at the night job and just trying to get the homework questions done. So, I've gone into Google and I've gone resistivity and temperature coefficient at 20 degrees Celsius, which is usually what they do it at. And I've looked up the three ones that I was looking for in our question for homework, which is silver, gold and platinum. So silver has 1.59 by 10 to the minus 8 ohm meters in resistivity, which is a very small number obviously, so it's very conductive. Gold is even more conductive at 2.44 by 10 to the minus 8. And platinum has an incredibly tiny number, 10.6 by 10 to the minus 8 ohms per meter. So platinum's an amazing conductor, but of course it's very, very expensive. And we're using our formula, resistance is equal to rho, the resistivity, times the length in meters over the area in square meters. So we know the y is 25 meters, so we'll leave that as it is. The diameter in our homework question was 3 millimeters. So we need to calculate the area assuming it's a round conductor. We know that our formula for an area of a circle is pi r squared. So I took my diameter in millimeters, I converted it to meters because we need to work out square meters for our area. So it's 0.003 divided by 2 to turn it into a radius. And then we calculated our area, and I expressed it as 7.07 by 10 to the minus 6. And I should put units there, shouldn't I? Which would be meters squared. So how did I do that on the calculator? If you're wondering, all you 4-unit math students will be going, duh, I know how to use a calculator, but for anyone that does have problems, and I've had problems in the past with, which buttons to push and whatnot, at the moment I've left it in scientific notation mode. You can see there, psi. That's going to be an issue too. So if you ever get lost in the calculator, it's not doing what you want it to do because it's in radians or something like that, you can go shift, push the shift key, and then hit 9 for clear. And then you can just hit 3 for all, and then you just go equals, because you're saying yes, and then you say reset all as all clear button. Boom, you're back to where you should be starting in normal mode. Okay, so that's the first thing you can do. So we're going to work out our area first. So we're going to say it's 0.0015, which is half of 0.003, and we're going to square it, which is our little square root button there, which is done. And we're going to say, what's that equal to? That's equal to that. And we're going to multiply by pi. Now pi, they use 3.14 in the textbook, but why would you do that when you've got this lovely pi symbol here? It's a yellow symbol, so you need to hit the shift key and then hit pi times pi. Answer times pi is equal to that. Now that's a rather small number, and we'd like to express that as a scientific number. So how would we express that as a scientific number? You go up here to shift, and we go to mode setup. And we can select 7 for our scientific mode. And I'm going to put in there 3 because I want to have 3 figures. And we get 7.07 by 10 to the minus 6. So that is our area. That's how I got to my area figure. Okay, so now we're going to just plug our resistivity into the equation. So I'm going to re-express this on a on another piece of paper, just so that you can see how it should be set out. So we've got our area, and we need to use our formula. Rho equals resistance is equal to rho, which we decided for silver was 1.59 by 10 to the minus 8, and we're going to multiply that by our figure for our area, which is 7.07 by 10 to the minus 6 meters squared. So that was ohms per meter. And then we're going to divide it all by, no, I tell a lie. I've stuffed it up. See, you have to watch me. I always make mistakes. 25 meters. We're multiplying by L, and then we're dividing by 7.07 by 10 to the minus 6. Now, if you're using this scientific notation method, you want to make sure that you put a brackets here, because otherwise your order of operations is going to stuff you up. Okay, because you're dividing. If you multiply that out first and then divide by that, it's going to do that answer first, and then you're going to be multiplying by that. You have to divide by this entire number here. So if you decide you don't want to use scientific notation, you probably won't need to do that. But just keep in mind order of operation is always going to be something that you might have problems with. So the 25 is the 25 metres. So it's rho for silver times 25 metres over this is our area in metres squared. Okay, so let's do that on the calculator. We're back in scientific mode again. So if you want to get out of scientific mode, shift, setup, sorry, I tell a lie, shift 9, go 3, all, hit equals, hit all clear, and we're back to our normal mode. So I'm going to go, I'm going to work out the top of this equation here, and I'm going to say 1.59 by 10, okay, to the power of negative 8, okay, and I'm going to say, and then I'm going to step across and go times 25, which is our meters, and that's the top of our equation. And then I'm going to divide it by, I'm going to bracket 7.07 by 10 to the power of minus 6, which is our area. And then if I close brackets, it's going to close bracket up here. Okay, so I need to step across and then close the bracket. Okay, and I hit equals, and I get a very small number. Now, I could just write that as a resistance in ohms, but you're really better off writing it as scientific notation, I think, for a very small number like that, seeing we started with scientific notation. So I could go shift mode setup and hit 7 for scientific, and go, I'm going to hit for 3 because I want 3 digits, and there it is there. So it's the resistance is equal to 5.62 by 10 to the minus 2 ohms. And that is your answer. And the working out for the other questions will be exactly the same. So give that a try, and yeah, and I might take you on a little tour of where I am presently, because I'm really bored. Okay, so off we go. This is the workshop at Sydney College of the Arts, and this is what I do at night. It's in an old lunatic asylum, and in another video I might actually take you into the abandoned hospital building if I'm feeling really brave. See you in the next video.